Timer and start. Okay, we are just waiting for the people or the participants to enter. Can we start already? Technical support? I can't see any participants other than the current one. Are we going to add or just live? Oh, okay. Good day, everyone. We're going to have today our first participant for the session, who is going to be Dr. Luzango Mfupe. Dr. Luzango is currently a principal. There is an expert in dynamic spectrum, access and management functions, telecommunication regulation, policy, satellite, high altitude and medium low altitude platform communication, and radio propagation modeling. Dr. Mfupe have provided expert consultants in the industry before to institutions like ICASA and other development environments, and in the development of TVWS regulations for South Africa. So I think with that, we may move over to Dr. Mfupe. Dr. Mfupe, you may start.
Thank you, Program Director. It's an honor to be here giving a talk at the CHPC National Conference. As the Program Director introduced me, Luzango Mfupe, I'm a CSIR employee at the Next Generation Enterprises and Institution Clusters. We are working on telecommunication field, in particular in wireless communication. And over the past few years, we've been doing a lot of work on the technology called TV white space. We've developed a number of toolboxes that are currently hosted by the CHPC. So I'll be talking about those toolboxes. We simply call them smart spectrum sharing toolboxes, which help to improve the spectrum utilization efficiency and also the bridging of the digital inclusion gap. So this is my presentation outline. We'll talk about the background and motivation. We'll talk about the challenge, called the double-edged challenge of connectivity and affordability. I'll provide a highlight on the radio frequency spectrum utilization and the concept of white spaces. Then I'll briefly give an overview of TV white space. What is it? I'll talk about the CSIR developed smart spectrum sharing toolboxes and the toolboxes that are currently hosted by the CHPC. And I'll also talk about the approach to bridge the digital inclusion gap using TV white space, fog or mobile edge computing and machine learning. And I'll conclude the talk. So to give a background and motivation, spectrum is considered as a crucial national ICT infrastructure resource, and it should be efficiently utilized and managed. Simply because any wireless communication requires radio frequency spectrum. Of course, there are some other means or other mediums which can be used for ICT, to provide ICT infrastructure like fiber or copper, but predominantly in recent times, it is very, very difficult to reach hinterlands, for example, in developing countries with such expensive means as fiber. So radio spectrum is very, very important because it allows the same ICT infrastructure to be provided via wireless communication. With the fourth industrial revolution, which now everybody is singing about, we are talking about connectivity of almost everything, from machines to human to machine, and so forth. So this brings about the need of actually optimization of utilization of spectrum, because it doesn't make sense to connect everything with, let's say, fiber. You need wireless means of communication to connect IoT and so forth. So spectrum here clearly comes to the fore with the advent of 4IR. There are some numerous reports, mostly from the World Bank, for example, which describes the importance of broadband connectivity to a society. In particular, in developing countries or emerging countries, a 10% broadband connectivity can contribute up to 2.3 percentage point of the GDP in terms of economic growth. So you can see that the linkage between spectrum and broadband connectivity and the GDP development of countries is very strong. They play hand in hand. To give you more motivation and background, as you can see on the image here, the United Nations SDGs or the development goals, sustainable development goals, clearly indicate the importance of broadband. You can see broadband is touching almost all the important sectors of our daily lives, from the e-health, SDG number 3, online education, SDG number 4, working from home, and especially now with this COVID-19 pandemic, there's increasing people working from home, studying from home. The reduced carbon emission, SDG number 13, with driverless cars and so forth, they will require broadband communication. And so forth. For example, the cyber security also, SDG number 16. You can't have effective cyber security without connectivity. So it's a double-edged sword, and so forth. So you can see the need of broadband connectivity is very, very high in our daily lives. So yes, we need connectivity, but again, here come the challenges. You can see, for example, in developing countries, in Africa, for example, in particular, most of the population relies on agriculture, smallholder farmers. And you can see this population need connectivity so that they can access their market, but they are not connected or efficiently connected or sufficiently connected. We need connectivity in improving our schooling in developing countries compared to the developed ones. we're still lagging behind. So in summary, currently there are around 3.2 billion people that are still not connected globally. And just recently, a recent ITU report has indicated that 33% of Africans are connected to the broadband or some form of broadband connectivity. Unfortunately, almost 80% of those 33% connected Africans are not adequately included, digitally included, because they're connected, but they can't sustain to be online or to use the internet, broadband internet affordably because of the affordability issues. Yes, they are under some form of broadband connectivity, but they can't sustain it. So they are connected, but at the same time, they're not utilizing the connectivity efficiently. So that is a challenge we have currently. So what is the radio frequency spectrum? So as I mentioned earlier, it's a medium that's used to enable broadband connectivity using wireless means. The image, the top one, shows the South African spectrum allocation chart. The middle image shows areas where a spectrum is being used and areas where spectrum is not being used, as you can see from the spikes. And the below image, or the third image, give a brief hint on how such spectrum, which is not being used in those areas, as indicated in the second image, can be utilized using dynamic spectrum access. So here comes the concept of white spaces. Those are the areas which are not utilized at a given period in the spectrum band of interest. So TV white space, what is it? Technology overview of it. So these are the unused portion of the radio spectrum that have been allocated primarily for television broadcasting. So when they're not used, then we call them TV white spaces. So these TV white spaces can offer up to 24 megabit per second broadband speed over distances up to 10 kilometers. With their superior propagation characteristics, they can penetrate man-made obstacles, even natural obstacles, hence make them very, very useful for rural broadband connectivity. TV white space can be used to digitally transform developing countries. This is a technology that the CSIR have been working, and we have some solution, as I'll explain in the next slide. So we have a TV white space regulatory framework in South Africa. The regulations were published in 2018 by the regulator ICASA. It's a three-tiered framework, which is as described on the image. You have the reference geolocation spectrum database. In the second layer, you have a secondary geolocation spectrum database. And the third layer is the network users and so forth, or the consumers of the broadband. So in a nutshell, this is how the regulatory framework will look like to enable the utilization of TV white space in South Africa. So the TV white space, like any other industry, this is a new industry, and it has a value chain. As shown in this image, there are many stakeholders from the manufacturers of white space devices. These are the devices used for providing broadband connectivity using TV white space. You have providers of value-added services. You have network planners, installers, network operators, and data centers. As you can see down on the arrow there, CHPC plays the role as the internet data center provider. in the entire value chain. So as I mentioned during my introduction, we have at CSIR, we have developed smart spectrum sharing toolboxes, which are currently hosted by the CHPC. And these toolboxes currently used to address the lack of affordable broadband connectivity. And typical use cases, for example, enabling the national ICT regulators, for example, the South African regulator ICASA, to automatically account the usage of spectrum in the country in real time, or any area of interest, as it might be deemed necessary by the authority. Also, it can be used to enable communication by network planners to dynamically plan creation of opportunistic communication networks and related models. Also enabling wireless network operators to dynamically access and share local spectrum automatically. The CHPC has hosted several toolboxes that have been developed by the CSIR team. The first one is called the National Local Spectrum Sensing Testbed, which is currently being used by a number of local and international universities, as you can see. The number of universities listed there, TUT, UWC, Fort Hare, and so forth. So this is a national test bed hosted by the CHPC for R&D and I in dynamic spectrum access. The CHPC has hosted the TVY space calculation engine for South Africa and beyond. The engine is used in South Africa to provide communication using TVY space. And also has been used for R&D purposes in Cyprus, in Ghana, in Botswana, in Tanzania, and various other countries not listed here. So bridging the rural and township digital inclusion gap with TVY space enable fog or edge computing and machine learning. So as I highlighted in the earlier slides that we have a double-edged challenge. There's affordability issue there and a connectivity issue. So some of people are not connected, others are connected, but they can't afford. So with the concept of TVY space enabled edge computing or fog computing and machine learning, content can be caged locally where the community live, and the community can access such content without using data. And the content can always be updated, for example, overnight. For example, if you are watching Netflix or any important digital content, the content provider can update it overnight, and users can access the content without accessing the data locally. They can only incur data costs when they want to go outside of their local networks, for example, accessing the World Wide Web. Of course, new business models need to be developed, for example, a pay-per-view or daily usage and so forth. But this is seen to be one of the promising approach to bridge the digital inclusion gap. The UNDP, the CSIR and other partners such as the UNDP and the FCDO are currently supporting women and youth-owned ICT SMEs to deploy TVY space networks in rural and township communities, as well as imparting digital skills to the SMEs to efficiently run this kind of networks. So in conclusion, I can say that RF spectrum is a crucial component of the national ICT infrastructure. The need of broadband connectivity have a direct impact to many sectors of the society. CSIR developed smart spectrum sharing toolboxes are meant to address challenges of affordable broadband connectivity. The CHPC plays a critical role in supporting the CSIR innovation by hosting the smart spectrum sharing toolboxes. And the locally caged content can address the issue of data affordability to bridge the digital inclusion gap. we humbly acknowledge the CHPC team for their profession support. Thank you. This is the end of my presentation. Any questions?
I think we just waiting for some questions to come through, because most of the question is on the live site. Maybe the site takes a bit of time. It's a bit behind than our normal Zoom presentation. But just a question maybe from my side, Dr. Mfupe. Let's say we use multiple platforms and do the digital inclusion for these different areas and different groups of society. At what level who will be responsible for the thing? Would that be the carrier itself, or how will how are we going to bill or put the bill to the customer if you use multiple platforms? For example, you move from fiber to a 3G network back to maybe but of a lower network, 2G or 1G network. So who's gonna, how is that gonna work, that component?
Okay, thank you. So it depends which carrier or which network operator you are subscribed to or with. As long as you have a subscription, you'll always be billed by your current operator, because operators have got roaming agreements. So if let's say you are moving from one provider to another, who are using different technologies, you'll still be recognized as a subscriber, and your bill will always follow you from the first provider where you subscribed with. So unless I didn't get your question correctly. Is it clear?
So it would be the responsibility of your actual carrier to split that cost.
Yes.
I think in this regard. Okay. It makes sense. Because one point of contact is going to be much more easier for users should we get to the point where we can actually allow them access. The other question I wanted to comment maybe, currently South Africa, one of the few countries in Africa that is actually almost fully, where you can actually fully, throughout the country, have access to some sort of spectrum throughout the country. One thing I've noticed was that while most of Europe and the West countries would move maybe from 1G, 2G, 3G over to your 4G and your 5G networks, and then discard the older networks, South Africa is one of the few countries that actually keep some of those older type of technologies in different type of environments. And I think that also allow to bridge the digital divide when when especially from a tourist perspective, sometimes people are amazed that depending on where they are, they still get reception, even if it's a bit of a lower quality also. So South Africa is very when it comes to keeping the old technology, because the old technology is some sort of innovation in a different environment. So there's something that is also quite active and clearly visible within South Africa.
Yeah, I agree with you in that sense. The problem in South Africa is a bit unique compared to other African countries, because first, here almost 100% actually, according to the latest report from the regulator, 100% of the population is already covered by some form of communication networks, and almost 100% of the subscribers are using smartphones. The issue is on the affordability now of the data. So that's the other part of digital inclusion, where you have people who are living in areas which are already covered by some form of communication infrastructure, but they can't afford to stay online. So it's a peculiar challenge. When you go to other African countries or other developing countries, you find they have both problems of not being connected by any form of communication infrastructure, whether it's old one or the new ones. And also those who are connected, almost 80% of them, they still can sustain being online. So yeah, those are the kind of challenges.
Okay, thank you, Dr. Mfupe. There's another question coming through. How do you see cloud playing a role in the locally cached content? Locally cached content, how do you see cloud playing a role in that?
Yeah, so the cloud still plays a role. So let me give you an example. For example, now we have, let's say, content from Netflix. You see, everyone is busy with Netflix and Showmax. If you want to access it currently, you need to have some sort of a subscription with MWeb or any other provider. And then you need to have sufficient data to access that content. Why? Because the data is hosted somewhere in Cape Town or in Joburg. So you need to actually to use the internet, your data bundles to access it. With the local cached data, you can have the same Netflix cached somewhere in Cape Town, there near the community, and keep updated overnight from the main data cloud center. So that's where the cloud plays the role. The locally cached one, they just do the offloading of that content to the local servers and get updated overnight, for example. So you can't remove the central cloud servers, but you support them from the edge using the concept of fog and mobile edge computing.
Okay, I think, thank you very much, Dr. Mfupe. Unfortunately for us, we ran out of time. Thank you very much for your presentation, and I think it's definitely something we're going to have to look forward to in terms of bridging the digital divide. And I think also that a lot of work is going to be forthcoming in that area, especially from a cross-industry, cross-scientific environment going into the future. If there's any additional questions, we hope to get it to you in some form, and then I'm not exactly sure how we will do that, but we will keep you posted. Thank you very much, Dr. Mfupe. Anything from your side? Any concluding remarks?
No, thank you very much, Program Director. Once again, I would like to thank the CHPC for their support. We've been together in this journey of trying to bridge the digital inclusion gap in South Africa and the rest of Africa. Thank you very much.
Thank you very much, Dr. Mfupe. Okay, thank you. We can move forward to the other presentation, technical support, and Dr. Mfupe is going to join us on the live stream. If there's any presentations Dr. Mfupe will still want to continue looking at on the live stream.
Thank you.
Thank you. Okay. I think that's it, Dr. Mfupe. There we go. We can move forward to, I think, Herman Leroux. Stop. Okay. Where do we start?
Good afternoon. I'll be presenting a short overview of this.
Let's introduce the speaker. Before you start playing the video, you can load it. Before you start playing, will introduce the speaker. Okay, yes, I will continue. Good day, everyone. We finished with the first presentation on telecommunication and bridging the digital divide by Dr. Luzango Mfupe. We continue. So next speaker will be Mr. Herman Leroux, who have been with the CSIR since 1998 and who's been a research group leader in the command and control systems in the defense and security cluster. Mr. Leroux is involved in command and control technologies as applied to the whole of government initiative across diverse domains, including defense, safety and security, public transport, disaster management, health and protection, and infrastructure and natural assets. With that, we will move over to Mr. Herman Leroux's video. You may continue technical support.
Good afternoon. I'll be presenting a short overview of the CSIR CHPC support during the National Department of Health Community Health Worker COVID-19 household screening campaign. The CHPC really assisted us, and as an introduction or just a context for the presentation. So this was at the start of the pandemic. The CSIR put up a COVID-19 response center in support of the National Department of Health. And one of the CSIR's platforms, the Cmod Platform, was configured and deployed to support the National Department of Health to collect screening data across South Africa using community health workers and using the Cmod mobile app. Initially, we understood that between 3,000 and 5,000 community health workers would be deployed. This quickly escalated to around 25,000 to 30,000 community health workers. And well, what also happened is our existing infrastructure and Cmod web platform was then quickly overloaded as this platform was not fitted with a proper front-end load balancing capability. We then, in coordination with the National Department of Health, and this actually fitted their deployment plans quite well, divided the problem up into the 9 provinces with an additional server for national or just as additional capacity. And that sort of the decision was then made to move over to a different infrastructure. Now, the Cmod platform, just to give you a bit of context, is a platform that allows for the integration of sensors, third-party systems and services, and other data sources, and then push data into a common dynamic data model. Now, using human operators to collect data is a critical part of this architecture, and the platform can be relatively quickly be configured and then deployed for data collection like activities. So this is the process that we generally follow for the deployment, rapid deployment of the Cmod platform. And in this case, it was a smaller questionnaire from the National Department of Health, so it was not a complex, long questionnaire. So this process was actually very quick. The most difficult part was to configure it properly to deploy it across the 10 servers. So just to show you the questionnaires, the final, I think this was the final set of questions that was defined. So this is one questionnaire just shown over 2 screenshots because it's just too long for a single screenshot. So you can see here the questions are really basic, and that it focused only on the primary symptoms at the time. So this was, remember, this was really at the start of the pandemic. So the focus was not here to dispense medical assistance to the members of the public, but rather to detect the spread of the virus and then also then point people to the nearest hospital if they were in need of medical assistance. So as I said, we deployed over our single existing infrastructure. It's not a big infrastructure. It's roughly 128 gig RAM, 20 CPU cores. From this, we created what we a Cmod template VM server based on the Windows Server 2019 and Microsoft SQL Server. And the CHPC then configured 10 virtual machine servers for us, each with 164 gig RAM and 32 virtual CPU cores. So we made a template, the template of the deployment, the Cmod deployment, and copied this to the 10 servers. And we could set this up relatively quickly. We had to make a small change to our mobile app so that the correct server can be selected by an operator upon initial setup of the app on a mobile phone. And yeah, I think this is actually, the case where the CHPC saved the day. If it was not for their quick response, I think we would have still have struggled to procure the 10 servers to deploy our Cmod infrastructure to. So this was really a quick activity. The biggest problems were to move and make sure the 25,000 accounts were correctly configured, and that the community health workers could successfully access the correct server and so forth. So there's the Cmod mobile app is a native Android app. So we also had some issues with some of the older Android operating systems and so forth. So a lot of the effort went into that and not really into any of the CHPC side of things. That was very quick and painless. We then continued to log data. So during the first 2 or 3 months of the pandemic, we ended up logging around 2.9 million, actually a bit more, probably about 3.2 million records. And you can see the statistics there. So we moved over the existing user base to the 10 servers. That actually also took quite a bit of time to move over all of the accounts. That was not so straightforward, and that's really a quirk of the Cmod platform, not necessarily it's not anything to do with the CHPC platform. That was really well executed, and we actually haven't had any issues with that. So in the end, we registered around 21,000 accounts. Active accounts remained very low, and I think the biggest issue was that as we finalized the deployment onto the 10 servers, the household screening demand declined. That was actually just how the timing of everything worked out. And I mean, the deployment onto the 10 servers was really quick. It was all the logistics around it that with the National Department of Health partners that assisted with the community health workers and so forth, that caused certain delays, and then eventually, yeah, we ended up not collecting a lot of data on the CHPC servers, unfortunately. However, what then also happened is that the Western Cape Government Health launched their own customized Cmod mobile app. They've had a slightly optimized questionnaire, and also requested some other small functionality updates. For that, 2 servers were earmarked, and we deployed it for them. However, their deployment was relatively, it did go well, but I don't think they collected as much data as they planned. And then 2 other projects both from Gauteng Province Department Roads and Transport for COVID-19 compliance for learner transport. So this is for registered vehicles, that was deployed as a questionnaire on the Cmod mobile platform, as well as a questionnaire for taxi rank managers. Now, these are from the same department, but it's in essence 2 different projects. And this is still ongoing to some extent, and it also is now changing into other projects with the Department of Roads and Transport, but that will, obviously, it's not COVID-19 related anymore. This is now more compliance, general compliance, and so forth related. The most active remaining deployment on the CHPC infrastructure is the support that we give to the National Institute for Occupational Health, their employee surveillance program. So there they offer a number of options to small companies to collect employee COVID-19 related data as legally required. So any company with 50 or more employees must submit their COVID-19 statistics to the National Institute for Occupational Health. And yeah, so Cmod is one of the options available. So most of the smaller companies don't have their own systems in place, and they might not be able to comply with some of the other options that the Institute offers. So Cmod is an easy way out, and this is actually where Cmod works quite well, is where lots of smaller groups have to be able to access it easily. So I'll show an overview of that project. So this is just an overview slide of the Western Cape Government Health case. This is still ongoing, but at a very, very low scale. They collected roughly 124,000 records around June. So from there onwards until now, the number of records collected is very low. They had around 600 active users, and the reason why they wanted to use the Cmod platform in this case was the ability to easily draw reports from the web interface of Cmod. This is just the other server. So on the first server they collected roughly 100, yeah. So you saw the statistic there. This is the second server. So here a bit more activity in terms of community health workers, and then slightly more records collected. So I think, yeah, the split that the Western Cape decided on was between the metro, the city-like areas, and then rural. So they split it across those 2 domains. This is the Gauteng Province Department of Roads and Transport, the learner transport compliance. So here the initial program was much larger, but I think one of the limitations here was that the vehicle drivers do not necessarily have access to the devices that the department believed they had to. So as I said, this Cmod mobile app is a native Android application, and it does have a minimum Android operating system version requirement. So here you see roughly 45,000 records. They wanted to record the destination school, and then in general, if people, learners in the vehicle, wore their masks, in general, sanitize their hands, that they observe social distancing, and were their temperatures checked when they embarked onto the vehicle. So here it is for registered vehicles only. They issued a sticker to a vehicle, and then they just wanted to see if there was a level of compliance when these operators, vehicle operators, then picked up learners and dropped them at school. So in the morning and also in the afternoon. So from home to school and then back from school to home. This is the taxi rank manager case. So here, a much smaller use case. Again, just overall, if vehicles in general are disinfected at a taxi rank, do passengers wear masks? Did they observe the 50% loading capacity at the time? And then is sanitizer sufficient and available at the taxi rank? So taxi rank has got a taxi rank manager and then some deputies, and they just wanted to make sure that taxi ranks observed the protocol at the time. The National Institute for Occupational Health case, this is the one that is still ongoing. So as up to the 29th of November, roughly 1,300 companies, so these are generally small companies registered on the platform. They have to comply with the 4 questionnaires for vulnerabilities, symptom screening, positive test, and then return to work. Now, these are quite extensive questionnaires. The vulnerability one and the symptom screening one is really long. The positive test one, obviously, to determine when the outcome was, the positive outcome was recorded, and then return to work, and in some cases where people were not able to return to work because of prolonged side effects of the disease or even death. As I said at the start, this is a legal requirement. So companies with 50 or more employees is legally obliged to submit this information to the Institute. This is the same platform that we used for the NDOH and Western Cape screening, so the same type of questionnaires, and then also you can see a screenshot there of the mobile app. So people generally submit the data via the web interface, but they could also use the mobile app, and there you see the 4 you select one of the 4 tags or templates to submit the data. I'm not going to show screenshots of that because it is a relatively long questionnaire, so it's extensive and comprehensive. That concludes then the presentation, and I do thank you for your time and attention, and I hope to be able to answer some questions. If not, please contact me there if you are interested in what I presented. And thank you to the CHPC for arranging this opportunity to present. And we do thank them for their assistance, as if it was not for CHPC, we really would not have been able to continue with the initial deployment to National Department of Health, and then also it would have limited the other projects that I provided an overview of. Thank you so much, and do enjoy the rest of your seminar.
I think that concludes our presentation for today. Thank you very much, Mr. Roux. As indicated by Mr. Roux, you can send all your questions to the email address that Mr. Roux have indicated on the video. That concludes our session for today. Thank you everyone for your participation. Mr. Roux will come back to your questions if there is any. And I think that concludes everything. Thank you very much, everyone, for your participation.